In this question, we're going to look at an A-star level question that uses integration by parts and a little bit of integration by substitution as well, actually. And I'm not going to tell you where that is, so if you'd like to have a go, go for it. But yeah, part I tells you specifically that you want to use integration by parts, so let's do that. So this is a special type of question that you need to know about. So I'm just going to quickly write out the equation here. So it's the integral of u dv dx is equal to uv minus the integral of v du dx. So we first make what we're integrating match the left hand side of the equation. The dx is already matched. So, but where are there two functions, u and dv dx? Because there's only one function of ln x here, right? Well, there's a trick to this. You have to separate it into 1 multiplied by ln x, because 1 multiplied by ln x is just ln x. Another tip I give is, when you're naming the functions u and dv dx, whenever there's an ln function, always call that u. It'll always help in the long term. So let's do that. U is equal to ln x, in which case the other function, dv dx, has to be equal to 1. Before we make it equal to the right hand side of the equation, we need to first find the value of v, or the function v, and we also need to find du dx. So we can easily just substitute it in. So du dx is what you get when you differentiate ln x, which is just 1 over x. And v is what you get when you integrate dv dx. Integral of 1 is just x. And you don't need to deal with the plus c, because we're going to deal with it later actually. Inputting it into the right hand side of the equation, we get is uv ln x multiplied by x, which I'm just going to write out as x ln x actually, just to simplify things. Take away the integral of v, which is x, multiplied by du dx, which is 1 over x, and then dx at the end. So x times 1 over x, this x cancels out with this x, leaving you with just 1. So this whole term here can be rewritten as the integral of 1 with respect to x. When you integrate 1, that's just x itself. So we have x ln x minus x, because 1 integrates to x, and then plus c. And that's it. That's the answer for part I of the question. Let's now use that to do 2 part A and 2 part B. So in part A of the question, you can have a go if you'd like, but whenever you're squaring a function, it's the same as multiplying that function by itself. So I'm going to rewrite this out as ln x multiplied by ln x dx. Now, I did mention that you want to call ln u whenever you can, because you want to make it match the left hand side of this equation. But in this case, we have to call the other function ln x dv dx as well. But it's okay because we already know what ln x integrates to now. We know that the integral of ln x is x ln x minus x. So we can say that v, which is the integral of ln x, is x ln x minus x. Once again, du dx is what you get when you differentiate ln x, which is just equal to 1 over x actually. Making that match the right hand side of the equation now, we have its u, which is ln x, multiplied by v, which is, sorry, I'm repeating ln so many times in this video, minus the integral of v multiplied by du dx, which is all of this multiplied by all of this. Let's write this out. Hopefully you spotted something that helps you simplify this multiplication, but I'm just going to write out in case you haven't. So because you're multiplying by 1 over x, you can actually divide each individual term by x. You're able to do that. And that leaves you with just ln x minus 1, all multiplied by 1, which is just ln x minus 1. So let's replace this with ln x minus 1 then. ln x minus 1. We're almost there now. So expanding this out, x ln x multiplied by ln x is just x ln squared x, or you can write x ln x all squared, because you're just multiplying ln x by itself. Minus x times ln x is just minus x ln x. We know ln integrates to all of this, so minus all of this expression here gives you minus x ln x plus x. So let's write that out. Minus x ln x plus x. Be very careful with this minus sign, because you do have to take it into account. When you integrate minus 1, that gives you minus x. But again, the minus here makes it that it's a plus x. Perfect. And now as our last step, we're actually able to simplify because there's 2 like terms. These two can combine to give you minus 2x ln x. So we have x ln x all squared minus 2x ln x. And actually the last 2 terms, x plus x, can combine to give you 2x. So that'll get you plus 2x. And that's everything. Oh, sorry. I always tell my students this, but you have to remember the plus c. Yeah, always remember the plus C. That's everything for 2 part A. So I'm just gonna highlight this and bring it up. It's getting a little bit messy. Okay, yeah, let's leave it there. So we have space to do part B of the question. I don't want to go down and then you're unable to see the question. So part B is actually really difficult to spot. If you have spotted it, well done, but you actually do use substitution here. The hint is whenever something's in a bracket, that tells you that you might use substitution. Not necessarily you have to, like here we didn't, we used parts. But actually, one giveaway factor here is we know that when we differentiate ln x, you get 1 over x. And you can multiply both sides by dx to get du is equal to 1 over x dx. Why do I mention that? That means that 1 over x dx, this whole section here, can be replaced with du. That sort of tells you that you actually do use substitution in this case. So this whole question, we can separate it into ln of ln x multiplied by 1 over x dx, because they're the same expressions. And then you can replace all of 1 over x dx with du. Not only that, but you can replace this inner bracket ln x with u, because you introduced it as u before. So now we have the integral of ln u du. We know what this is because we did it in part I of the question, and it specifically made you do it in part I so that you can use it here. So instead of x, everything is just in terms of u, so it's going to be u ln u minus u. U ln u, ln u minus u plus c. Lastly, you want to input in everywhere where there's u, you want to replace it with ln x. So we have ln x, ln of ln x, all take away ln x plus c. And that's the answer to the question. Very difficult question here, but hopefully it all made sense and you can make some sense of it when to use integration by parts, when it's impossible to sort of replace everything in terms of u, and when you use integration by substitution, where you spot that, okay, ln differentiates to 1 over x, so you can somehow manipulate that in some way. Thanks for watching the video, and be sure to like and subscribe if it helped. And I think I have a playlist full of more A-star level videos. If you'd like to challenge yourself, have a go for it.